This is TWiT.
All right, so don't freak out. Rare earth metals aren't really that rare. Now, if you played Minecraft, you've probably resonate with you a little bit. It's dirt and ore, right? Well, in the tech industry, rare earth elements are used in technology devices, but due to their expense and acquiring them, that's actually difficult, makes things more expensive. But actually, the United States Geological Survey describes rare earth metals and elements as moderately abundant and just difficult to extract from its surrounding matter. So let's get to examples. So oxygen, silicon, aluminum, iron, they essentially make up 90% of the Earth's crust and are well dispersed around the planet. An interesting one is cerium, which is actually the 25th most abundant on the Earth, making it about as common as copper, but just hard to extract. Unlike copper, gold and silver type rare earth elements don't clump together. So due to their chemical makeup, and the rare earth elements actually adhere or bond to their surrounding materials, making it really hard to extract. So in order to extract them, you have to filter, sift, dissolve in acid, filter, sift, hundreds of times more and more, and finally you get the element. Well, in the 1960s and through the 80s, the USA actually supplied the world with a lot of the rare earth elements from a single mine in California in Mountain Pass, but it actually closed in 2002 because of its expenses. But China actually decided to bite the bullet and take on some of the annoying processes with using cheap labor and overlooking some of the environmental issues. And by doing that, they were able to take on the cost and produce and sell a lot of the elements, rare earth elements out there. But until just recently, they were able to corner the market. Japan, off the coast of Japan, called Minami Torishima Island, also known as Marcus Island, is actually 1,800 kilometers off the Japan mainland. They found an estimated amount of 16 million tons of rare earth elements. Essentially, some of them are used in technology, and some of them are actually used in smartphones and hybrid cars. What did they find? Well, they found things like 730 years of dysprosium, which is actually used in magnets and hybrid cars, 780 years of yttrium, which is actually used for manufacturing of lasers. But how does this kind of essentially relate to a lot of the technology? Well, Hitachi, Mitsubishi, they usually have products that use these substances, but it makes them less efficient if they have to go to other compounds because they can't acquire them. And because China corners the market, they actually hold on to 90% of the rare earth elements. It makes it really hard and really expensive for companies to use them. That's where kind of the news from Japan comes in. They say there's plenty of other elements in the world, and they can circumvent the control of China's global supply by doing something that's actually described in the Nature Scientific Report, which says that they have a process that they could use called hydrocycle, where it uses centrifuges to force and quickly separate out the necessary elements in the sea mud, and do this at industrial scale. Brian, is this going to change the market? Is this going to change our reliance on a country like China and actually open the market to be able to use these different elements?
You bet. And what I need to point out is everybody remembers the OPEC oil embargo of the 70s. I sat in line for God knows how long waiting for my ration of gasoline. Well, our friends in the Soviet Union tried that. And what they did was, they drove up the price of rare earth elements in a pretty big way. They drove it up enough that it actually became economical to reopen some mines that were previously not viable. So like the one in California, the one in Colorado. Now, let's put this in perspective. So a modern gold mine isn't like the 49ers digging down into the earth with pickaxes and so forth and donkeys. No. It's actually dirty. It's on an industrial scale. There's actually this giant thing that actually looks like a sand crawler out of Star Wars. It actually goes along a riverbed. It picks up the mud. It drops it, rinses it out, drops it in, crushes it, drops it into a massive vat of mercury. And everything else floats up, and then a big giant arm sweeps off and cleans off the mercury from the dross, the trash, and then at the bottom is heavy. And then that goes over and over. So at the end, you get these gold nuggets that are mixed in with all kinds of other junk. Now, then they crush that. They actually powderize it with steel balls and so forth, and then they dissolve junk in acid. And it's actually not just one acid. The gold process can be as many as a half a dozen to a dozen different types of acid, going up to something that's just absolutely horrid stuff. It is a horribly, horribly dirty process. This is the same process for rare earth elements. In fact, one of the things that China is doing is they have these tiny little villages that are burning old circuit boards. You know that e-cycling that we all think we're helping the earth. Well, they're burning it on open pit fires, and then they're taking the ashes and they're giving it to these companies that then start dissolving them in acids and different things. And it is an environmental disaster because our friends in China, in their race to corner the market on rare earth elements, has just completely turned a blind eye to the ecological impact. Now, this is one of the reasons why the California and the Colorado mines shut down, is they were actually working on finding more efficient and less ecologically damaging processes. There's a whole bunch of researchers using things like graphene sieves, microstructures, so that they can more efficiently remove the dross from the stuff that you want, to be able to go and get those rare earth elements out of the mud. Literally, it's mud. And when we're talking about that island off Japan, it's pulling it out of the seabed. It's this mud. It's all mixed up. A lot of people don't realize that seawater isn't just salt. There's a lot of other things in there, lots and lots and lots. So there's actually a picture of one of the islands, the artificial island that they're using to explore all this. And literally, things like lithium. We all talk about lithium batteries for computers, lithium batteries for electric cars and things like that. If these researchers can figure out how to more efficiently pull lithium out of suspension or lithium out of other materials, the sea actually has more than enough lithium in it to supply our need for lithium batteries for the millennia. So now what's happening is when supply becomes restricted and the price starts going up and demand isn't dropping back, what you start getting is people going, there's got to be a better way. And that's what's happening. Scientists are working on more and more efficient ways of pulling rare earth elements, including gold, silver, yttrium, and so forth, out of suspension and do it cheaply and at scale. And that, I think, is the promise for the high-tech industry, because we need these elements. There's a lot of things that we need that just don't work without these rare earth elements. And, Lou, sorry, the scientists in me just kind of went crazy. I've got a science background, an engineering background, and I just find this stuff absolutely fascinating because I'm actually working with a researcher that says that there's a way for him to create this microstructure that literally he just blows liquid carbon dioxide across a stream of salt water with this special microstructure, and with no moving parts, we would desalinate water. So now we're talking about just something simple like desalinating seawater and making fresh water available very, very cheaply. The world's changing, my friend.
Yeah. So what I think I want to take a little bit of the psychology, physiological side of things. Like I want to talk a little bit about, now that the fact that we found a way, a set of processes to extract some of these things, make them more prevalent, more readily available to the manufacturing processes, making sure that we pay minimal amounts for them to actually get them. That kind of puts our dependence back on them, right? I mean, now that you're saying, hey, we can extract lithium from the ocean much easier now. Now let's go build some more lithium batteries. But is lithium batteries really the next generation of technology that's going to allow us to kind of evolve as in the technology industry? Like if we look at the example that we gave in the blips around, copper, now coating that with graphene, now it makes it more sensitive, if not just as sensitive as things like silicone and other things. Now, if we're saying, hey, let's go find more silicone, make it more readily available, more prevalent, does that mean that we'll just keep working with silicone and stay with the current trajectory of Moore's law? So do you think that this might maybe have a reverse effect on our evolution in technology?
I think it's kind of like If We Build It, They Will Come. The baseball movie. The issue is there has been a huge uptick in things like electric vehicles because of the efficiency of lithium batteries. Now, directly to your question, I actually have the privilege of working with some researchers that are doing a lot of battery research. And one of the things that's happening is there are some really stupendous new developments in the way you use lithium to make the batteries dramatically more efficient. Like lithium iron ferrite batteries are actually starting to take the uninterruptible power supply business by storm. So in our industry, UPSs are a pretty big deal, right? We all know that. Mm-hmm. But we have to plan on every couple of years of changing out this massive bank of batteries. So right now we're using lead acid, the gel lead acid batteries, which is good because in the United States, 95 to 98% of the lead acid batteries are completely recycled because they're easy to recycle. Now, we aren't recycling lithium because it's hard. So I think what we're going to have to we're starting to get this cycle. We're getting new technologies to recover metals out of solution, which the same technology can be used to recycle lithium batteries. So yes, as it becomes more prevalent and the price starts dropping, we're going to have more people using the technologies, more lithium batteries or lithium derivative batteries for vehicles, for airplanes. We're already starting to see the first all-electric airplanes starting to hit the market. All real interesting. But because of the technologies making it more efficient to get the rare earth elements, lithium included, now all of a sudden we've got this loop that's building. So we're using it more, but now we have the technology to recycle it, which means the supply lasts longer, the price drops. Now we have more and more of the material able to be used, less and less expensive. So I equate it to when really low-cost broadband started becoming available. Until higher bandwidth was available, streaming video just wasn't possible. Now that broadband is relatively ubiquitous, we'd like it to be better, but relatively ubiquitous, we've got more and more technologies using the higher bandwidths. I think the same thing's going to happen to rare earth elements. Technology, Moore's Law and so forth, all hinge on materials to build the technology to be reasonably inexpensive to the point where it's a commodity market. So, yeah, I think the technologies to pull out the rare earth elements, to create a larger supply of rare earth elements, means we might start having people creating some really unique applications. Keep in mind, things like virtual reality goggles require a lot of rare earth elements, and that's one of the things that makes them kind of expensive. But if the rare earth elements are a lot less expensive, now all of a sudden VR goggles start dropping in price. Could you imagine what would happen if we had VR goggles, say in the really good VR goggles under $100, what the industry might look like? So I think this is, talking about the very building block of our industry.
Right. But I think I'm hoping that this doesn't have a negative effect, because I really think that, because it's just kind of like supply and demand. In the case of supply and demand, you have a lot of competition, and you offer if you have a lot of supply, sometimes the cost goes down. It doesn't cause a lot of it causes the need for competition, and when competition comes along, then it causes kind of the evolution. And so we kind of relate this to elements. If right now, since the elements cost so much to get, we're finding new ways. We're kind of going down those paths of finding new ways to develop new technology in order to do things that we need to do. Like, for instance, build better batteries, longer life, have more power cycles on them, have better CPUs, have smaller transistors, that kind of thing. And so we're kind of forced in that direction because of the cost of some of these things. And so we're developing new technology to circumvent those costs. And so now that we're saying, hey, by the way, Now you have those elements. And so now it's almost like a deterrent to say, hey, let me go figure out and fund some new research into that technology. I really hope that doesn't happen, because we need to continue to move forward and sometimes actually get off the need to some of these elements. So we'll actually have to see what happens in the future, because hopefully this is not kind of a negative effect, right?
Yeah, well, I kind of want to flip the coin on the other side. If they become more available and we start building new things that need it, that's going to drive the demand, and it's going to make people still be creative. But keep in mind, once we get to a tipping point, in this case, my tipping point for this entire industry is actually really inexpensive space travel, SpaceX and all those. Because if we really and truly want those rare earth elements in large quantities, there's nothing better than asteroid mining. So I think the world's going to change. My crystal ball's just as good as yours. Maybe that should be part of our predictions. What do you think?
Yeah, absolutely. Well, one thing is obviously getting off the reliance of a specific company or country to actually export these things. I think that's kind of the key to here as well, is kind of opening the door and not being reliant. Kind of opens the market for more things. So I definitely feel that that's a definite positive thing. And by opening the market, we have more money to work with, and then it kind of becomes a domino effect for better things. So we'll just have to see kind of where it takes us in the future.
Yeah, this week in geopolitics. Woohoo!